Okay, polynomial equations. Okay, find the function graph's end behavior. There's two things you have to know about the end behavior, and I kind of illustrated that in yesterday's video, what it's talking about. If you graphed it, positive infinity is what's the graph doing this way, negative, what's it doing this way, up or down. Okay, so you have to know the leading coefficient first off. You can abbreviate LC if you want, and then the degree. Okay, leading coefficient is -2, so since it's a negative, we're going to approach we're going to go to negative infinity on this side. Okay, and then the degree is 6, which that's the highest power, that's even, so you have to have matching end behavior, so you got to match the end behavior there. Okay, leading coefficient is 2, +2, so we're going to approach positive infinity. And the degree is 5, which is odd. So you're going to, they will not match. Non-match. So out of non-match, it's negative on that way. Okay, now I illustrated in the video yesterday how these i's and irrational roots work. Okay, so I'm going to just go straight into it. Okay, all these are rational, they're all real, so they don't have a match. Or excuse me, they're all rational, they're meaning there's no square roots over the top of them, and there's also no i's. So you don't put like +3 or -4 or -12. They don't have opposite partners like the square roots and the i's do. So x minus +3, x minus 4, x minus 12, boom. Remember, the i's and the square roots are the ones that come, the irrational square roots are the ones that come in pairs. Because the square root of 5 is irrational, so it has an irrational partner. And all these have partners then. Okay, so the first thing you have to do is just write it out, x minus, and then go plus square root of 5, and x minus the square root of 5, and then x plus 7i, x minus 7i, and then x plus 3i, x minus 3i. Now all these pairs need to be multiplied using shortcut methods, these two, these two, these two. So I have these x second, positive times a negative is a negative, and then the square roots just come off, and you have just whole, integer 5. Okay, x second. Now, I know that's a positive times a negative, but the I to the second then reverses it to positive, and you have 49. Don't put the I. Shouldn't see any square roots, any i's with that. And then likewise here, x second plus 9. That's the answer. Okay, y equals, now that one doesn't come in a pair, it's real, okay, it's rational and it's real. When I say real, that means there's not imaginary, there's no I, okay, and also it's rational because you don't see a square root over the top of it, so that does not come in pairs. This one does, -4i, negative square root of 6. So x minus +3, x minus +4i, x minus and then 4i, x plus the square root of 6, and x minus the square root of 6, okay? And then we need to simplify the pairs, okay? So x plus 3 didn't have a pair. So x second, and then plus 16, because remember, again, I'll explain why that's plus. Because that's negative, but then the I squared reverses it into positive, because I squared is -1. Then you have x second minus and then 6. Okay, there's that. Find all the roots of the equation by factoring. I have a mistake here. This is a 60. That needs to be that 27 needs to be a 60. Otherwise, it's not going to be able to be factored. Okay, there would be 3 roots. Okay, and then when you're factoring, you got to count the terms. There's 3. So GCF table. The quadratic formula should not be used on these problems. Okay, it's since it tells me I have to factor, then it's not going to make any sense for Hermsen to be writing problems where the t-chart ends up prime, because that stops the factorization from happening, okay? So just know that. Just getting something right here. Okay. All right, GCF 3, 3, and 60 is 3, and you also got to take x with the 3. So 3x. Now, right now, set that 3x equal to 0, divide by 3, and that's your first root. Solution, root, same thing. Now divide them all by 3x. That's a 60. So 1x to the second plus 1x minus 20. 20 is now a constant because the x's go bye-bye. Okay. It's going to be negative 20, so I'm adding to try to make positive 1. 1 and 20, and it's negative 20, so it's, I think, positive, negative. That doesn't add to negative to positive 1. Divide by 2, you get 10. Nope. 3 is a decimal. If you divide by 4, you get negative 5. Now that's negative 1, but if I go plus 5 minus 4, then I'm good. Okay, A is 1x to the second. So you can ditch the 1 and just forget it, and then you can just make 2 parentheses, but you got to split your x squared. So xx minus 4 plus 5. Now, neither one of these have second powers, okay? So I'm done factoring. Don't do adopts when the second power is not there. Don't even think about it. You just go x minus 4 equals 0, x plus 5 equals 0. And then the other roots would be 4 and negative 5. Okay, number 7, x to the fourth minus 12x to the second minus 64 equals 0. We have 4 roots here because of the fourth power. And then I have to factor 3 terms. So GCF table. GCF 1, 1, 12, and 64 is 1. We would not take the x this time because that constant, that number at the end is already a constant. Okay, so it's just 1. Don't do it. Okay, 1 multiplied by negative 64 is negative 64. So that's a positive times a negative, and I'm adding to try to make negative 12 out of it. Nope, negative 63. Divide by 2, you get 32. Nope. 3 is a decimal. If you divide by 4, you get 16, and there's negative 12. Now be careful here. A is 1x to the fourth, so you can ditch the 1, okay? But since it's x to the fourth, we make 2 parentheses still, okay? But now I call it x second, then plus 4 minus 16. Now since we still have second powers, we're going to take these over here. And we're going to see if we have perfect squares. So xx, 2, 2, that's perfect squares. That's perfect squares. Plus minus, and then right here, plus minus. Those are kind of branches. XX, 2, 2. Now you got to check, if you have a plus sign, you got to put I, okay? XX, 4 and 4. And if you have a minus sign, you leave the I out. So those are all your factors. You got 4 of them, which makes sense because you got 4 roots. We didn't do a GCF, okay? So x plus 2i equals 0. So you minus 2i, and that's negative 2i. So if I have negative 2i, then that second one's going to give me positive 2i. And then it's going to be x plus 4 equals 0, negative 4, and then positive 4. Okay, now remember that we have to come back and look at that on a problem at the end, okay? Number 8, x to the third minus 5x squared minus 4x plus 20. I still want you factoring. This time there's 4 terms, okay? 4 terms, we go to the grouping method of factoring. And one thing about the grouping, remember to check for adopts down there, okay? That's important that you remember that because this might be. Okay, so I put 1x cubed minus 5x squared, negative 4x plus 20. So we look to divide. 1 and 5 would be 1. X cubed and x squared would be, again, you got to take the x squared at the end so that this becomes a constant. Okay, 4 and 20 would be 4. And you wouldn't put an x because 20 is already a constant. It doesn't have an x. And then put negative on the 4. Okay, so I factor out 1x to the second. And here I factor out negative 4. So it's going to be 1, and that goes down to all the way to x minus constant 5. No x on that. And this will be the same thing, 1x minus 5. So these parentheses match. They're a match. So 1x minus 5 goes here. And that's my first factor. I'm going to use that factor to get my first root. Now the other two roots, I put the 1x squared with the negative 4. Put minus 4. Don't put plus negative. Now in DOPS, I would drop that 1, okay, because I know that's xx, that's 2, 2. You have a minus up there, so the i's are not needed, okay. Every root I get is going to be real. There's going to be no imaginary roots. That's F2 and F3. Okay, so 1x minus 5 equals 0, and that's 5. X plus 2 equals 0, so it's going to give you negative 2, and then the other one's going to be positive 2. Now sometimes the real rational roots do have pairs, but they don't always, because like that 5 didn't have a pair, the 2's did, but the 5's didn't. This needs to be changed to number 7. Refer to your solutions from problem number 7. Take the graph, list the following. Now you use your roots, find your roots. Your roots are the solutions, and that's number 7. Negative 2i, 2i, negative 4, and 4. X-intercepts. X-intercepts are the roots, but they're not the i's, okay? So you just write the ones down that aren't i's, the real roots. And the y-intercepts, you just take out all the x's and you have negative 64 would be the y-intercept. That graph would cross the y-intercept, the y-axis at negative 64. Okay, dividing polynomials. Okay, first off, I got 1, 5, negative 1, negative 5. Then outside I set that x plus 5 equal to 0, and I'm going to circle that. That comes in handy a couple times. So negative 5 is the outside divider. It's divisor. 1 times negative 5 is negative 5, then I add, and that's 0. Add, you get negative 1. That's 5, and now I'm at 0. Okay, so now what happens there? Well, this 1 now here goes from an x cubed to an x second, okay? Now this would be an x, but since it's 0, I'd skip over it, and then I put minus 1, and there's no remainder, so that's my quotient. Remember, this last one's always your remainder. If that's not a 0, you got to put the number over the x plus 5 expression. Okay, next one, we got 2, negative 7, and 13. So I take that x minus 4, so my outside divisor is 4. Drop the 2, 2 times 4 is 8. Don't put 8 here, you got to line it up here, and that's 1. Negative 3. Okay, here I didn't get a remainder of 1. Okay, so that 2 that used to be x cubed is now x second plus 1x minus 3, and then I put plus 1 over the expression x minus 4. Okay, and that's how that's rewritten. Now, you wouldn't be able to solve an equation like that, find roots, but that's the quotient of it. Okay, now I want to cross out the net. We're going to do this problem, but I want to write a different equation, please. Okay, the equation I want you to write is x to the third minus 5x to the second plus 2x plus 8 equals 0. That's my new one. Okay, use the rational roots theorem to find the solutions of the equation. So there's 3 solutions, but we don't go to factoring. You wouldn't be able to factor this anyway. If you tried grouping, it wouldn't work because those 2 parentheses wouldn't be the same. That would end up x minus 5. That would be x plus 4. It wouldn't work. So RRT. So you take your 8, and in front we got a 1. I like it when we have 1s. Limits the possibilities, which is always good. Factors of 8, 1, 8, 2, 4, and then 3, and then you're back to 4. So I really don't need to divide them all by 1. So my possibilities are 1, 8, 2, and 4. Pretty short and sweet list. Now I'm just going to get my other roots going off this, my first root going off that list. So I've got 1, 1 to the third, minus 5, 1 to the second, plus 2, 1, plus 8. Okay, that obviously didn't work. Now let's go to 2. I would go in order. Remember, if it's not a story problem, you need to switch them to negatives, okay? Okay, I don't need 2. 2 I got, okay? So 2 is your first root. So now I synthetically divide by 2, because x minus 2 is a factor of that expression. So 1, negative 5, 2, 8. And you will get a remainder of 0. When you have to find roots, you have to get the remainder to be 0. 1 times 2 is 2. It's going to be negative 4, negative 8, 0. Now what happened? Well, that 1 now goes from an x cubed to an x squared. Now it's down to a quadratic equation. Minus 3x minus 4 equals 0. Now I'm going to run that b squared minus 4ac on my calculator, so negative 3. And I think some of you can see that this is not going to be irrational. Okay, you didn't get a decimal, so I want the GCFT chart run. I want it factored then. Unlike yesterday where I got irrational. GCF would be 1. It's going to be negative 4. And we'd be adding to get negative 3. Okay, so 1 and 4 right there. Okay, so that's easy. So A is 1x to the second. You can ditch the 1 and just rewrite it in 2 parentheses, breaking that into x plus 1 minus 4. And that gets me my other 2 roots. So this time all the roots are real, they're all rational as well. So negative 1 and 4. Okay, then there's a whole lot of nothing. Then you got these things, simplify the expression, exponent properties. Underline it, you have 3x and y. 3 is to the first, but it's in a parenthesis, so we got to distribute that second to everything. So that's going to be 2. Now there's 2 x's. The first x, you got 2 times 2 is 4. And then they're both on top, so it's plus 2. Multiplication exponents need to be added. Then y, 3 times 2 is 6. Now all those would stay where they're at. None of these are negatives, so I don't need to bring anything down. 3 to the second needs to be simplified. That's 9, and then x 6, y 6. Okay, I got 4xy. 2, negative 6, and 10. I don't need to add anything because every base appears once. Okay, the 2 and the 10 stay, so 4 to the second times y to the 10th, and then the x goes downstairs, so it's 6. This can be simplified to 16. Boom. 15. You got 4 times a times b times c. Now on bottom I got a, b, and c again, but I already wrote them on top. I don't need to write them on bottom. 4 is to the first. Now nothing's in parentheses, so we just drop the exponents. Now a, there's 2 of them, okay? But this time they're being divided, so it's 1 minus 5, which is negative 4. Okay, it's minus. B, again, the B's aren't being multiplied like the X's were here. So it's going to be 6 minus 1, which is 5. 3 minus 3 is 0. Now, anything that's 0 power is 1, but having multiplied by 1 means that is obsolete, so get rid of it. Okay, the 4 and the B stay up where they're at. Move the A down, it becomes 4. So 4 to the first is 4. Booyah. Okay. Okay, story problem time. Again, with these shape problems, that's how I'm going to set it up. I'm not going to be drawing a bunch of boxes. That's with like units, feet, seconds, and all that, paths. This really can't be represented with a graph, so it's not worth doing. It probably could be, but it'd be just a waste. Margaret is planning a rectangular garden. Its length is 4 feet less than twice its width. The area is 170 square feet. Find the dimensions down there. So you're equal to 170. Now you can only have one variable though. Now how to get this to one variable? Well, I write that equals. You got length, and then just put 4 feet less than twice the width. So I put width, and then twice its width would be 2. 4 feet less would be minus 4. So in that L parentheses, I put 2W minus 4. I don't want to put L. And then here I just drop the W. Now it's all in terms of one variable. So 2W times 1W, negative 4 times 1W. So 2W squared, negative 4W. Now those are not like terms. Nothing can be combined. So it's 2W squared minus 4W. It's a quadratic equation. And there's a W to the first, so we have to move that 170 out of there. Now, should I go GCFT or just straight to quadratic formula? Well, that depends on what our discriminant tells us. Yeah, I need to use quadratic formula. That T chart's not going to work. Opposite of B plus or minus the square root. B squared minus 4AC over 2A. Opposite of B is 4. I'm just going to get rid of this square root and put 37.09. I mean, I just pretty much calculated that. You can draw it out. You're going to get the same thing, assuming you do everything right. And A is 2. So I got 4. 2 times 2 is 4, and you can drop 37.09 there. $10.27. That'll work. The other one's probably a negative that I'm just going to end up crossing off, but I'll figure it. Negative 8.27. Ditch a negative, and also don't put that as your length. Okay, 10.27 is your width. We don't measure in negatives. So 10.27. So 2 times 10.27 minus 4, and that gives me 16.54. Again, you can multiply those together, and it should be approximately 170. Okay, next one's the same setup, except it's volume. It's 3-dimensional instead of 2. A cube length is 1 more unit than the height. A cube's width is 2 less units than the height. Cube's volume is 12 cubic units. Find each of the dimensions. Okay, volume's 12. Volume is length times width times height. You got to write that all in terms of one variable using these little is. 1 more unit than the height, so I put height plus 1. You don't put a number in front because it don't say twice. None of that. Width is 2 less units than the height, so that's h minus 2. So in the L parentheses, I put h plus 1. W, h minus 2. And then h is just h. Again, the multiplication is not that big of a deal here, okay? You just FOIL these two. H times h times negative 2, 1 times h, 1 times negative 2. I'll put a 1 there because I'm going to need it later. Negative 2h, 1h, and negative 2. So it gives me 1h to the second, and combine those, negative 1h minus 2. Now, don't just drop that down because you still have to multiply by h. But that's easy. That just goes to 1h to the third minus 1h to the second minus 2h. Now, unlike the last problem where there was 2 roots, there's 3. So that throws out the quadratic formula. You can only use quadratic formula if it's actual quadratic equation with the second power, first power, and constant. Okay. We're going to clear that 12 just like we did the last one though. And I would suggest you go to your rational roots theorem. Don't try to factor it by grouping because it's not going to match. Some of you who are good with, because that's, yeah, just go with your RRT. So you got 12. Don't worry about 12 being a negative. And then 1 in the front. This over this. 1, 12, 2, 6, 3, 4. Factors of 12. Divide by 1 is 12, divide by 2 is 6, divide by 3 is 4. Okay, so that makes 1, 12, 2, 6, 3, and 4 my possibilities. So I'll substitute those in for h. No, go to 2. Nope, go to 3. 3 is a possibility. Booyah, 3. Now you're like, well, what about the other 2 roots? Who cares? 3 is a real root, it's a rational root, it's a positive root. So 3 is a good answer for H. A lot of people think they find all 3 and that's what your length, width, and height is. No. Okay. 3 and 1 makes 4. 1. Okay, last problem. And that's a negative 1 right there. Okay. The profit in millions of dollars of a t-shirt manufacturer can be modeled by this weird equation here. X represents the number of t-shirts produced by the million. Currently, the company produces 4 million t-shirts and make a profit of $4 million doing that. What lesser number of t-shirts could they produce make the same profit? Okay, write your equation. Your equation's given to you, hook line given to you on a silver platter. How they got it, I have no idea. I got this out of one of the textbooks. Okay, so what I should do is make a box and tell what the variables mean. P is money, profit, and X is the item. This time it's t-shirts. If you want to put items, that's fine. So you have 4 million t-shirts, so just use 4. Don't put a bunch of zeros there. You'll just put million down at the end. And money, you got 4. So you're going to put those in. Yes, you're going to put 4 in at the same time. Now plug that in, see that it's equals to 4. Just make sure you, this is to check to make sure everything's written right. So you don't do a bunch of, because if you forgot to put like the negative on the 1, it's not going to equal out, so you know something's up. That you had something written down wrong. Yep, 4. Good. Now we want to keep the same profit. We want to turn these 4s in back into X's and find other roots. That would equal 4 as well. Put the 1 there, you'll need it later. So the equation has 3 roots, and you already have one of them. You don't have to use the rational roots theorem because I just a moment ago had 4. They gave me that one, 4. So set up your synthetic division, but you have got to clear that. You can't do this Yeah, quadratic formula, the roots theorem, all that stuff. In higher order polynomials, you have to have one side equal to 0 before you can find the roots or the solutions. -1, 4, 1, -4. -4 plus, that's 0. 1, 0. Now, how do you rewrite that? Well, -1 used to be x cubed. X squared, x cubed, so now it's -1 x to the second. Now we're not going to have an x because I got 0. This 1 is a constant and then it equals 0. Now I don't need to factor this, okay? I just need to get the x squared by itself, find what the square root is, and that's the final two roots, one positive, one negative. Divide by -1 by -1 is 1. And now I apply the square root to 1, which is 1, okay? 1, -1. Ditch the negative, and those are your answers. So X is t-shirts, so put mil tees, mil tees, million t-shirts.